all. Good morning. In our last video, we have discussed about solubility product and solubility. You know that solubility, it is a quantity which denotes how much amount of solute can be dissolved in a particular amount of solvent at a particular temperature. Generally, by solubility we understand it is the maximum number of moles of solute that dissolves to prepare 1 liter of solution at a given temperature. So, the unit of solubility is mole per liter. You know that salts are of 3 types: highly soluble salts, slightly soluble salts, and sparingly soluble salts. Sparingly soluble salts, their solubility is less than 0.01 molarity. And these are the salts which can attain an equilibrium system in aqueous medium between the dissolved ions and undissolved solid. That equilibrium constant is known as KSP, and the expression of KSP for different types of solute in terms of solubility is different. Solubility and KSP, the relations you have understood in the last lecture. I have derived some relations depending upon the number of constituent ions of each type. Now, today I shall discuss 2 problems before you. How to solve these problems? Look at problem number 1. How many moles of ammonium chloride should be dissolved in 1 molar ammonium hydroxide to prepare a buffer of pH 9. So, Kb for ammonium hydroxide is given. Kb for ammonium hydroxide is 2 into 10 to the power minus. Kb for ammonium hydroxide is 2 into 10 to the power minus 5. Now see, according to the solution, according to Henderson Equation, we know that for basic buffer, it's a basic buffer because it's a weak base, so therefore it will be a basic buffer. Basic buffer constitutes a weak base and it's solved with a strong acid. So according to Henderson Equation, pOH of basic buffer equals to pKb plus log salt concentration by base concentration. This relation, salt concentration by base concentration. This is for basic buffer. For acidic buffer, the relation is pH equals to pKa plus log salt concentration by acid concentration. These are the 2 equations known as Henderson equation for solving the problems related to buffer solution. Now here it is given pH 9. pH of the buffer solution is 9, means pOH is 5. pH plus pOH equals to 40, so pOH equals to 5. Kb is given. Concentration of the base is given 1 molar ammonium hydroxide. You have to find how many moles of ammonium chloride should be added. Let's consider n moles of ammonium NH4Cl be needed. So you consider n moles of ammonium chloride be needed. Therefore, putting the value here in this equation, we get pOH equals to 5 equals to pKb is minus log of Kb. Kb 2 moles of ammonium chloride should be dissolved in 1 molar ammonium hydroxide solution to prepare a compound solution of pH 9. This is the way to find the answer. So you have understood it. How many moles of ammonium chloride would be needed? Number of moles of ammonium chloride would be needed equals to 2 moles of ammonium chloride. This is problem number 1. So Henderson equation, you will keep it in your mind that for basic vapor it is POH equals to pKb plus log salt by base, and for acidic vapor pH equals to pKa plus log salt by acid. These two equations are important for vapor solution. Now come to question number 2. Question number 2, you see that what is the question? What volume of water should be required to dissolve 1 gram of calcium sulfate at 25 degree centigrade temperature? KSP of calcium sulfate at 25 degree centigrade temperature is given. This is the value of KSP. From the value of KSP, it is clear that calcium sulfate is a sparingly soluble salt. Very less solubility, which is almost insoluble in water. So see, this calcium sulfate CaSO4 is a sparingly soluble salt. It dissociates to form calcium ion plus sulfate SO4 2 minus ion. This is very small dissociation. Almost apparently we see that salt is not dissolving in water, but it is very slightly soluble, which cannot be understood, cannot be examined from externally. You cannot examine it. Solubility is such less. Now it is a type of heavy type of salt. Therefore, KSP, the relation of KSP and S will be KSP equal to S square, because the solubility of calcium sulfate considered as, so S into S, therefore the solubility KSP equal to S square. Okay, now KSP equal to S square, therefore this is given, KSP value is given, therefore S square equal to 9 into 10 to the power minus 6, therefore S equal to 3 into 10 to the power minus 3. This is equal to 0.0003 mole per liter. That means calcium sulfate is such a salt whose solubility is 0.003 mole per liter solution. So 0.003 mole, you have to convert it in terms of gram, because it is given 1 gram calcium sulfate. So weight of calcium sulfate, weight of CaSO4, this is equal to number of moles into its molar mass. Molar mass of calcium sulfate, calcium is 40, sulfur is 32, oxygen is 4 into 60, 64. This is equal to 136 gram. This is the weight of 1 mole of calcium sulfate. Weight of 1 mole of calcium sulfate, 136 gram. Therefore, number of moles equals to 0.003 into molar mass of calcium sulfate 136 gram. This is equal to multiply 0.408 gram. So 0.408 gram, this much of calcium sulfate will dissolve in 1 liter solution. See here, this much of calcium sulfate will dissolve in 1 liter solution. Its solubility says it. 0.408 gram calcium sulfate will dissolve in 1 liter to make 1 liter solution. So you have to find what volume of water should be required. What volume of water should be required to dissolve 1 gram calcium sulfate. 1 gram calcium sulfate is very small amount, this much, 1 gram calcium sulfate. To dissolve 1 gram calcium sulfate, what volume of water should be added? So see, it is given that 0.408 gram CaSO4 dissolves in 1 liter water. 0.408 gram calcium sulfate dissolves in 1 liter solution. Therefore, 1 gram calcium sulfate dissolves in 1 by 0.408 liter water. So if you calculate it, this is 1000 by 408, 1000 by 408 gram. This is equal to, what is 1000, what are they? 1000 by 408 equals to 500 by 204 equals to 250 by 102, 250 by 102, cancelling by 2, 500, 204, 250, 102, and then again cancelling 125 by 51 gram. So 125 by 51 gram, 51 liter, not gram, liter water, 51 liter water, this liter water is equal to 2 point divided 125, 51. This is clear here that 0.408 gram calcium sulfate dissolves in 1 liter water. Therefore, 1 gram calcium sulfate, to dissolve 1 gram calcium sulfate, you need 1 by 0.408 liter water. So 1 by 0.408 liter water means 1000 by 408 liter. We come to know that it is 125 by 51 liter. Calculation shows that it is 2.45 liter. So 2.45 liter water should be added to 1 gram calcium sulfate. This much of calcium sulfate, 1 gram, very small amount of calcium sulfate. To dissolve completely, 2.45 liter water would be needed. So this is how you have to solve these problems related to solubility product, related to buffer solution. So this chapter is now over. Equilibrium part, from the very beginning you have the concept of equilibrium in physical system, equilibrium in chemical system, features of equilibrium, important features of equilibrium. Now you have equilibrium constant. Again, it is of two types: equilibrium constant in terms of concentration, equilibrium constant in terms of partial pressure, Kp and Kc, their relation between Kp and Kc. Then you have reaction quotient Qc and Qp. Then you have Le Chatelier's principle and effect of pressure, temperature, concentration and inert gases upon the equilibrium system. This is the first part. Second part is ionic equilibrium. First, the ionization of water, Kw constant, pH plus pOH equals to 14. Equilibrium, this is constant for aqueous medium, any aqueous solution. Then you have concept of acid base, Lewis concept, Bronsted concept, Arrhenius concept. Then you have weak acid, weak base, dissociation constant of weak acid Ka, dissociation constant of weak base Kb, how to find their pH and pOH. Then you have common ion effect, and its application for weak electrolytes. Then solubility product, buffer solution, hydrolysis of salts. These are the topics. This is the entire chapter. So mostly numerical based. Boys, you are instructed to practice the numerical problems so that you can handle in your examination. Regarding your annual examination, today I am telling you some important things. The chapters taught, the portion that will be taught by 3 teachers, myself, S.J. sir and Abhinav sir. Their entire syllabus will be included in your annual examination. concerned, don't confuse my part, SJ sir's part and EWS sir's part. All the three parts will be combined to prepare your question paper. So don't confuse, don't worry if any part is left from your syllabus. That will be done in timely. So if it is not related to exam, it will be done later. So see it here, you should not be worried about it. You should prepare the topics or chapters taught so far and the topics or chapters which are being taught now. Remember it. So today I finished this chapter, chemical equilibrium. Your Abhinav sir is doing, I think, thermodynamics. After thermodynamics, he will also start a new chapter, and I will also start a new chapter for you. SJ sir is also doing some part of your chemistry part. So the entire topic taught. My point is that you should highlight the topics taught so far. That will be included in your syllabus. That will be included in your examination. Your examination will start from in the month of March. So keep entire Feb, the topics which will be taught will be coming in the examinations. Okay, boys. If you have anything, any queries, any other question related to examination that you will ask, okay, any doubt, but the portion which has not taught, question will not come from that part. Remember it. The portion or the chapter which will not be taught before the exam, before the annual exam, question will not be said from that part, that chapter. So it is clear. So today, if you have, I think, second part, NCERT second part, redox reaction has been taught. Redox reaction second part has been taught. I think that S block, P block, and organic, basic principles in organic chemistry, and hydrocarbons. This entire part is left, as I have been reported by the students of class 11. So this entire part is left. So regarding examination, we will not set any question which was not taught to you. Remember it. So don't worry. You start preparation. You start your preparation for every chapter. Chapter wise you prepare. The portion taught. You see the portion taught by the teacher in that particular chapter. That portion you revise. You know that in chemistry section, especially mole concept, states of matter, thermodynamics, and equilibrium. These are numerical based. So practice the numerical questions. Okay, boys? Thank you. So today I close my class.